Okay, here's a mechanics problem, just a speed, distance, time problem, but it's pretty challenging because of the algebra involved. What we have are two women who are running around a track. One's faster than the other. They start at the same time, and one laps the other in 5.5 laps. I realized just a minute ago that in this solution I've got the names turned around in my solution, so you'll just have to bear that in mind. No big deal. So here's what's going on. Two runners start at the same place on the track, and they start running around. One's faster than the other, and after 5.5 laps, the faster one laps the slower one. So the faster woman has gone 400 meters, it's a 400-meter track, farther than the slowest person. So we'll divide these up into Samantha and Emily, and again I've got these backwards. I'm assuming that Samantha's the faster runner. So Samantha's going to run 1,800 meters, 5.5 laps, excuse me. And then that means that Emily will run 1,800 less 400 because she's been lapped. She's run one fewer lap than Samantha. They both do this in the same amount of time. So we can write down speed equals distance over time expressions. So the speed of Samantha is 1,800 over t. We don't know the time, and that doesn't matter. And Emily is 1,400 over t. So I can flip those around and solve for the time. The time is equal to 1,800 over the speed of Samantha, and the time is also equal to 1,400 over the time of Emily. Now, because these are both equal to the same amount of time, we can use the transitive property to hook them together and eliminate time. So we have 1,800 over the speed of Samantha is equal to 1,400 over the speed of Emily. And then we can solve for one or the other of those speeds. So let's say that the speed of Emily is 1,400 over 1,800 times the speed of Samantha. And let's see, 1,400 over 1,800, we can cross out the zeros, divide by 2, so it's 7/9. So the speed of Emily is 7/9 the speed of Samantha. Okay, so we got that far. Now what we need to do is to try to figure out the distance that Emily ran. That's one of the things that we don't know. Well, we know that the time for Samantha is for Emily is 5,000 meters minus some distance over the speed of Emily, which is 7/9 the speed of Samantha. And we also know that the time is for Samantha is just 5,000 over the speed of Samantha. That's the time for the full 5,000 meters. And we'll use the transitive property again to hook those up. So we'll say 5,000 minus d over 7/9 the speed of Samantha, oops, should have had an s up there, is equal to 5,000 over the speed of Samantha. Now the speed of Samantha cancels from each side. Let's see, to give us some extra space, let's take this to another sheet. So we were left with 5,000 minus the distance over 7/9 is equal to 5,000. If we multiply both sides by 7/9, we'll clear that 7/9 on the left, get rid of that fraction in the denominator. And so we have 5,000 minus d is equal to, let's see, 5,000 times 7 is 35,000 over 9. We'll multiply both sides by 9 to get 45,000 minus 9d is equal to 35,000. And then I can move the negative 9d over to the right and the 35,000 over to the left. And I get 9d is equal to 10,000. And then 10,000 divided by 9 to get the distance is going to be 1,111 meters, or 1.11 kilometers. So that's the head start that Emily's going to need.